Hi everyone, so thank you for watching this video. So for this video I will explain about plastic analysis of frame using the virtual world method. So there are two categories of mechanism in portal frame, which is number one, the free mechanism, and number two, combined mechanism. So for plastic analysis of frame, there are three types of mechanism. Okay, so first is the beam mechanism. Okay, so this beam mechanism, you can see that from this part. Okay, when load apply on top, it will cause a beam mechanism where the hinge is here. Okay, the plastic hinge, and then it will cause a mechanism like this. So also, okay, you will have a sway mechanism. Okay, when you have a force apply, and then you will have a sway. Okay, sway to either here, or either to these directions. Okay, so this is sway. So also when you combine this beam mechanism and sway mechanism, then you will have a combined mechanism. Okay, where we combine the beam mechanism that cause this one and also the sway that causing it to sway. Okay, to the left or to the right. So generally the numbers of free mechanism, okay, the ME, can be determined by using the formula of ME equal to N minus D, where N is the positions number of plastic hinge that might be occurred. Okay, so it's the total hinge. So we know the fixed support, we have the hinge. Okay, and then at the joint we have hinge. So, and then at the load applied we have another hinge. So for this case we have 4 hinge, the plastic hinge. And then the D is the number of redundant, which is equal to R minus 3. So for this case, you can see that we have reaction, which is 3 reaction, the fixed support, and then the peak support we have 2, which is total of 5. So 5 minus 3, which is 2. So total of redundant is 2. Okay, so ME is equal to N minus D. Okay, so it's equal to 4 minus 2. So it's 2. Okay, means that for this frame, this portal frame, we have a 2 mechanism. From one is sway. Okay, one is sway, and then another one is from the pin. So total mechanism is 2 plus 1, means that one sway, one beam, and then one combined. So it's 3 mechanism. Okay, so let's go to the examples. So this example 1, determine the maximum moment plastic from the frame shown below. So we have a pin support A, pin support D. Okay, so we have 4 reactions, and then we have 20 kilonewtons here. Okay, so, push at the B joint, and then we have a C joint with uniform distributed load along the beam. Okay, along this member BC, 10 kilonewton per meter. Okay, so what will it cost? So as draw in this is a combined figure that I have drawn. Okay, so from the force, it will, from the 20 kilonewton, it will cause the sway, and then 10 kilonewton, it will cause these shapes of frame. Okay, so first thing what we have to do is we have to determine, okay, how many mechanisms it has. So ME is equal to M minus D. So now reaction is 4, and then the N is 3, where is the plastic hinge. Okay, so at the joint we have 1 hinge, 2 hinge, and then caused by this force, it will have another hinge for the MP here, and then here have no hinge because this is pin support. Only fixed supports have plastic hinge. So the redundant is 4 minus 3, which is 1. So 3 minus 1, which is 2. So total mechanism is 2 plus 1, which is 3. Mean that you need to have 3 mechanism. One is the sway caused by 20 kilonewton. Another one is this beam mechanism from 10 kilonewton per meter. Another one is the combined okay, the combined versions. So this is 1 plus 1 plus 1, so equal to 3 mechanism. So first we go to the first mode of failure, which is the beam mechanism. Okay, you can either start with the beam mechanism or sway mechanism. It is the same, you have to calculate all. Okay, so the first caused by the 10 kilonewton per meter, it will cause a HE here, the hinge here. So you will have theta P and theta C here, and also theta E. The calculation method is just same with the plastic analysis of beam. Okay, you get the theta P, which is HE over 2.5, and also it is equal to theta. Assume theta B is equal to theta, where tangent is neglected because of the small value. So HE is 2.5 theta. So theta C is equal to HE over 2.5. Okay, so is equal to also theta. So theta E is equal to theta B plus theta C. So is 2 theta. So external work is equal to internal work. Okay, for the virtual work method. So for the UDL, okay, UDL is half times length times HE times dW is equal to MP theta B plus MP theta C plus MP theta E. So you solve this, you will get MP is equal to 15.625 kilonewton meter for this mechanism 1. Okay, and then mode of failure 2 caused by the sway from this 20 kilonewtons from the horizontal force. Okay, so this horizontal force, when you apply on the portal frame, it will cause it to move to the right. Okay, so you have here you will have a theta A, and then here you will have a theta P, and then here you will have a MP. Okay, because it's moved, here you have a HB and you will have a HC. Okay, HB and HC here, and then this is another hinge. Okay, caused by the caused by this joint at joint when the force applied, and then here you have a theta C, here you have a theta D. Okay, so here is 6 meter, here is 4 meter. So theta A is equal to theta B. So you can see that this theta A is equal to theta B, okay, which is also equal to theta. And theta C is equal to theta D. Theta C is equal to theta D. HB is equal to HC. Now we assume they have a same the total movement. Okay, the HB and the HC is the same, we assume. Okay, so theta A is equal to HB over 6 is equal to theta. So HB is 6 theta equal to HC. Okay, so HD is equal to theta D is equal to HC over 4, which is 6 theta over 4, which is 1.5 theta. So theta A and theta B is 1 theta, and then theta C and theta D, okay, theta C and theta D is 1.5 theta. So external work is equal to internal work. Same methods. Okay, so 20, because it's point load, so 20 kilonewton times the HB, okay, is equal to MP theta B plus MP theta C, which is the MP located part. Okay, so 20 times 6 theta is equal to MP theta plus 1.5 MP theta. So after you solve it, you will get MP is 48 kilonewton meter. Okay, so now let's look at the mode 3, which is the combined mechanism of ABCD. Okay, so you have 20 kilonewton apply from the left, push toward here, and then you have 10 kilonewton per meter, the UDL load. Okay, so this is a combined mechanism. So you can see that we assume tangent theta A is equal to theta. Okay, and then theta A and theta B is equal, so theta B is also equal to theta. So this is theta B, this is theta A, and the HB is equal to HB. Okay, so HB is equal to HC, and then theta A is equal to HB over 6. Okay, so HB is equal to 6 times theta, and HE, okay, so HE here is equal to 2.5. Okay, the distance from H the here to here is 2.5. Okay, times theta b. So it's 2.5 theta times theta b. Okay, so theta c1 is equal to theta b. Okay, the theta c1 is equal to theta b. So it's equal to theta. And then the theta c2 is equal to hc over 4. Okay, so theta c2 is equal to hc over 4. Okay, hc over 4. So it's equal to 1.5 theta. So the theta e and theta b, theta is equal to theta b plus theta c1. So this is the theta e. So it's equal to 2 theta. And then after we obtain all of this, now we can use the equations of external work is equal to the internal work. So HB times 20 plus, okay, the UDL load, the 1 over 2 times L times HE times dW, okay, which is 10, okay, is equal to MP theta E plus MP theta C1 plus theta C2, okay. So you solve this, you substitute, you solve this, and then you will get MP, you rearrange it, is equal to 40.56 kilonewton meter. So by comparing three failure modes, so the maximum MP is equal to 48 kilonewton per meter, which 48 kilonewton meter, which is from the mode of failure 2. Okay, so this is the other example, the next example, example 2. So you can see that determines the correct loads PU from the frame shown and show all the MP for each of the mode. Okay, so you have P over 2 applied at point B, okay, horizontally, and the P applied at point E. Okay, and then here is MP for the AB, and then at B to C is 2 MP, and C to D is MP. So you need to be very careful with this. And also the length is L over 2 each. Okay, so let's look at the solutions. So the solution of this, we have three failure modes. So determine the correct slot PU from the fractions and all the MPs for each mode. So we have the three modes here. So let's look at the first failure mode. Okay, so first failure mode, we will look at the P applied at here. Okay, so the beam mechanism of BC, okay, B to C, the plastic hinge occurred at point B, C, and E, which is this P, C, and E. And then at B is MP, okay, and then at this point E is 2 MP, and then point C is MP. Okay, this is from the questions for this MP, 2 MP, and this MP. Okay, so assume tangent theta B is equal to theta. So the theta B is equal to HE, okay, over L over 2, okay, the length. Okay, so this is the L over 2. So you solve it, you get HE is equal to theta L over 2. And theta C is equal to HE over L over 2. So it's also equal to theta. And theta E is equal to theta B plus theta C. So it's equal to 2 theta. And then once you get all this, so now we can use the equation, which is the external work is equal to the internal work. So for the point load, okay, the P times HE is equal to MP theta B plus 2 MP theta C plus MP theta, 2 MP theta E plus MP theta C. So you substitute all the value in all the theta, and then you put into it the HE, and then you rearrange the equations. You will get P is equal to 16 MP over L. Okay, so now let's look at mode of failure 2, which is the sway mechanism A, B, C, D. Okay, due to this P over 2. Okay, so the plastic hinge should occur at A, B, C, and D. Okay, A, B, C, and D due to this sway mechanism. So theta A is equal to theta B is equal to theta C and is equal to theta D. So all of it is equal to the theta. And HB is equal to HC. Okay, so now look at this. So theta A is equal to HB over L over 2. Okay, L over 2. So it's equal to theta. So you rearrange it, you will get HB is equal to L theta over 2. So you will get is equal to HC. Okay, so now we have all the theta and all the h. So now we can use the equation of external work is equal to internal work. So HB times P over 2 is equal to NP theta A plus NP theta B plus NP theta C and NP theta D. So you solve this, you rearrange this, you will get P is equal to 16 NP over L. Okay, and then now we look at the combined mechanism A, B, C, D, okay, for the mode of failure 3, the last failure mode. So here you have P over L, okay, cause the sway, and then here is the P applied at the beam for the beam mechanism. Okay, so you can see that we assume the tan theta A is equal to theta. So theta A is equal to theta B. HB is equal to HC for this. Okay, and then theta A. So your theta A is equal to HB over L over 2 is equal to theta. So you rearrange it, you will get HB equal to HC and equal to L theta over 2. And HE is equal to theta B over 2. Over times L over 2, so it's equal to L theta over 2. Okay, and then theta C1 is equal to HE over L over 2, and then you substitute this into it, you will get HC1 is equal to theta, and theta C2 is equal to theta. Okay, so theta E is equal to theta B plus theta C1, so it's equal to theta. So after you get all of this, then you can start to use this equation. External work is equal to internal work. Okay. So for the P over 2, you times the HB plus P times the HE. Okay. For the external work is equal to NP theta 1 at A plus 2 NP theta E. Okay. Here is 2 NP. Remember. Okay. So plus NP theta C1 plus theta C2 plus NP theta D. So after you solve this, you will get NP is equal to 10 times 67 NP theta. Okay, so the maximum collapse load here, we are choosing the smallest value, which is the 10.67 NP over L. Okay, so for the loading, we are choosing the lowest value because the structure is already failed at the lower load instead of going to the higher collapse load. Okay, so now let's look at this another example, which is the example 3. Okay, determines the collapse load PU from the frame shown and show all the MP for each mode. So you can see that you have support A, B, and C, and then here is 4P, this is 5P. Okay, applied at point E and G, and then you have MP, 2 MP, 2 MP here, 3 MP, 2 MP. Okay, so you need to be alert when you do the calculations of this kind of structure that giving different MP. So let's look at solution of this. So you can see that here how many reaction we have. Okay, so reactions here we have is 9 because it has 3 fixed support. And how many redundant we have is D is equal to R minus 3, so it's equal to 6. Okay, and then how many positions of hinge we have it here. Okay, so N is equal to, you have 1, 2, 3, 4, 5, 6, 7, and 8. So we have 8. Okay, so we have 8 here, so M is equal to 8 minus D. Okay, so it's equal to 8 minus 6, so it's equal to 2. Okay, so which means that we have 2 plus 1, which is equal to 3 mechanism. One, we have the beam, okay, that caused by this 4P and this 5P, and then another one is caused by the sway, and then another one is caused by the combined. Okay, so how can we calculate it? Okay, so because here you can see that the beam analysis, we will have to calculate one by one. Okay, so first we will calculate this part of mode of failure, the F1, and then followed by we will calculate the mode of failure 2, which is caused by the 5P, and then the third one, what we have to calculate? We have to calculate that caused by the 3p. And then for the combined versions, okay, we will have two cases now. So what we expect is we will combine this 3p and 5p and see what is the the value of p. And then we will follow by the last case where we combine all 4p, 5p and 3p false and see what is the p that we will obtain. So let's look at the mode of failure 1, okay, which is caused by the TF at the beam DF. So you have 4p applied here. So you have MP here, 2 MP here, and this is MP, okay. So here is MP, okay, and then here you have 2 MP. That's why here is 2 MP and here is 2 MP. So when you solve it, okay, you solve the theta and then you put in the external work, and for the internal work you need to be careful when the 2 theta is putting in 2 MP, okay. So when the bin you have 2 MP, MP, 3 MP, 2 MP and MP different value, so you need to be careful with it. Don't make mistake here. So after you solve it, you will get P is equal to 1.75 MP over L for this first mode. Okay, then we will go to mode number 2, which is the beam mechanism of half hash. So now you have a 5p here and then 3 MP at this side, 2 MP at this side and 3 MP at this side. So after you solve everything, okay, be careful with this MP, and then you will get P is equal to 1.47 MP over L. Okay, the method is same with the plastic analysis, for the beam is similar, okay. The concept is similar, the method is similar also. Failure 3 is caused by the sway mechanism of AD half hash CP. Okay, so when it's 3 P applied, so it will cause the beam to sway towards this direction. So the MP occurred will be at here A, D, F, B, hash and C. Okay, so you have to obtain the theta A, theta P, theta C, theta D, theta F, theta hash. Okay, and then all are the same. We assume that they have the same theta, and then theta C we found out the value is equal to theta, so HF is equal to 2 theta L. So external work is equal to internal work. So 3p times HF is equal to MP. Okay, so for the first one is MP. Okay, is times theta A plus theta D and theta P, and then 2 MP for this member B half is theta P plus theta F, and then 2 MP for this member CD is theta C plus theta hash. So after you solve this, you will get P is equal to 1.67 MP over L. So now we will go to the mode of failure 4, which is a combined mechanism caused by 5 MP and also 3 MP. So for this case, what will it cause? Okay, so when you see this, look at this, you will have a sway. Okay, you will have a and then D, okay, caused by the sway, and then the B, and then for the combined version, when you do this at the point of at the sway and the beam mechanism points here, it will have no MP at here. Okay, just like same cases of the other two examples before. Then you will have a MP at G, which is caused by this 5p, and then you will have a MP at hash and also MP at C. So after you obtain all the theta A, B, D, C, have H1, H2, here is H1 and here is H2, okay, and then you obtain the HF and also the HG, okay, HG and HS. Then you will solve it by using all the theta. Okay, then you solve it by using external work is equal to internal work. So 5p times HG plus 3p times HF, okay, is equal to internal work, which is MP theta A plus MP theta D plus 2 MP theta B plus 3 MP theta G, okay, and then plus 2 MP theta C and 2 MP times theta H1 and theta H2. Then you solve it, you will get P is equal to 1.19 MP over L. Okay, so next, and this is the last, okay, for the combined mechanism, where we combine the 4MP and 4P, 5P, and 3P. Why we didn't combine the 4P and 3P? Because we can estimate that when the lot applied 5P and 3P combined together, it's supposed to be greater than the 5P over 5P plus 4P. So that's why we only choose one, only to skip it, okay, to get the answer faster. So when you combine everything here, so the MP here you will have MPA, MPB, MPC, but here you will have no MP. You will have a MPE, MPG. Here also you don't have it, but then you have you will have this MP at here, but here you don't have it. Okay, for the square versions, and then here you will have one as hash. Okay, so you solve the theta for theta A, theta P, theta C, D, F, hash. You solve everything theta, and then you calculate the external work here. Because this is too long, so we break it to external work and also internal work. So after you solve the external work and internal work, and then you rearrange it, you will get P is equal to 1.31 MP theta over L. So by comparing 5 cases, you will get the maximum PU is 1.19 MP over L, which is the lowest among the 5 cases. Okay, so you need to practice, and then to get your understanding about the plastic analysis for frame more, and then you can do practice more other than this old example that I have explained here. So thank you for watching this video. So I hope I help you guys in doing the plastic analysis for beam and also portal frame. So see you again.